Assalamu alaikum. Good morning, good afternoon, good evening. Can you hear me properly? And your is okay. Thank you. So first of all, we will start our free webinar. This is regarding the lightning protection risk assessment and protection design studies. It is the webinar regarding the intro of the lightning protection and design study. First of all, I welcome all of you in the free webinar. Then I will I'm sharing the screen for the PPT. Can you see this the screen?
No,
You cannot. Everyone, can you see the screen?
no screen not sharing.
Okay, okay, okay. Stop again.
Please, this class is recorded. Then we will be.
Now you can. Can you see the screen? The PPT screen?
No sharing screen.
No sharing.
No, no. Yes, screen sharing.
Now, kindly tell me, it is visible the screen?
Yes, screen sharing.
Okay, okay.
Please be record. So I
Uh,
benefited in future.
yes,
Using.
I'm recording this the video. Okay, first of all, welcome all of you in the free webinar. This webinar is regarding the lighting risk assessment and protection design, hosted by the AH Creative Energy Solutions. I'm Azizul Hassan, the solar design engineer as a project lead in the international firms. I have almost 7 years of experience in the solar designing field, and also I'm giving the professional training on the different topic like the solar designing and the now on the protection studies. So I'm also the founder of the AH Creative Energy Solutions. The purpose to build the AH Creative Energy Solution to give the freelance services on the different solar designing and also to give the professional trainings. I want to give the practical knowledge to the solar engineer and fresh graduates to confidently they will enter in the solar industry. So the purpose of this topic, basically, why the lightning protection study is required. Basically, when the lightning inside incident increases due to the climate changes, so there are the different issues created, like the uh, like so when the light strike on the different solar projects or any other buildings or any um, like hospitals and other different areas. So the issue there are the multiple losses created, like the life of the humans will affect through this, the loss of the different equipments like inverters and like panels, and due to that there are the loss of the equipment, human life and structures, and thousands of the structure and electrical system are damaged due to the electrical lightning strike and induced surges. So that is why the purpose of this um, study is required. If you are a solar design engineer or a electrical designer, you must need the requirement of this study to give to the client, to satisfy the client. So for that purpose, I'm just building a webinar regarding this issue. I want to discuss this issue with the multiple audience in this field. So that's why I organize this webinar to give the intro to the audience regarding this lightning strikes. So the webinar objective is to understand the lightning phenomena, learn the concept of the risk assessment, overview of the protection design approach, real world application in the solar and industrial study. First of all, when we need to design the solar system or any other electrical system, and we have to design the risk assessment study. First of all, we analyze the risk present in our area where we are installing our system, our solar system design, solar. So for that area, we need to analyze the risk of the lightning strikes. On that basis, if the risk is under the limitation of the as per the IC standard, then we don't need to provide the protection for this. But
Martin,
when
inyamuran sudan ne.
sorry.
Haka, afa. Thank you.
uh, when the risk is
Da Allah. Ya aikin ne? To nufa.
kindly mute is
Sudan ce to.
kindly kindly mute.
Oh, okay.
wallahi da mun magana kai na je na ce abin ya kwanta min asali ban san wai banci a material faida
Your unmute option is closed. Is it?
So sorry for the interruptions. Basically, when the light strike on the structure and any electrical system, we need to analyze first of all the risk of that lightning strike, and if the risk of that striking is under the limitations as per the IC standard, then we no need to provide the um, electrical protection of the lightning strikes. But if the risk is higher than the limitations, then we need to provide the lightning protection design, and like the finials and the lightning arresters, surge protection devices. So we have to provide that. So first of all, there are the four type of the sources and damage to the structures. Basically, the lightning current is the source of the damage. The following situation shall be taken into account depending on the position of the point of the strike related to the structures. Basically, when the strike lightning strike is occur, there are the different positions where they can occur in the field, in the electrical systems. Uh, Basically, the lightning current is the source of the damage. So there are the four types of the sources where they can occur the lightning strike, and due to that, the lightning current will flow and damage the equipments and the lives and the different issues created. So there are the four types of, like one is the flash to the structure. If the strike is lightning strike on the structure, one is that source. The other one source is that the S2, the flash near to the structure, not actually on the structure like the buildings or the solar structure, but it is near to the structure. This is the second source of the strikes and the source, and the third one is the line connected to the structure. Basically, flash to the lines connected to the structures. Where the HV line, electrical transmission lines, which is connected to the structure, and the strike is strike on that lines. So this is the third source of the lightning. And the last one is the near line, like the flash near the lines connected to the structures. So these are the four sources of the lightning strikes. Due to that, there are the different damages and losses occur. So we will see in the next slides. And the other one is the lightning effect and then the losses. When light flashes the lightning, there are the different losses. Four type of losses occur. One is the loss of human lives, including the permanent injury. The other one is the loss of the service to the public. Like there are the different services to the public. These will be damages. And the third one is the loss of the cultural heritage, like the heritage is present in the area, and the lightning is the flashes. Due to that, this is the third type of the loss. And the last one is the loss of the economic value. Due to that, the value of economic is low down due to this the striking. This type of the four type of the losses occur due to the four type of the sources available in that area. I have discussed in the previous slides. So due to that losses are striking, there are the different effects, the like the puncture of the electrical installation, like where there are the some installation is occur, like I have shown the solid structure picture, that in that the lightning strike and they will damage the solar panels. Fire and material damages, when the lightning is strike, it might be chance that the fire will grow, or the material will damage. These are the factors. People in the intensive care and difficulties. like when the light is striking on the hospitals. Due to that, electrical system, the electricity distribution system will damage due to that lightning strike. And there might be a chance that there are some humans are in the intensive care options due to when the light is cut down due to this lightning strike. There are the chances of human life losses. So this is the and the rescue immobile peoples. So these are the effects of the lightning on the due to the losses. And then we will go to the risk assessment concept. So when basically what is the risk? Value of probable average annual loss humans or goods due to the lightning relative to the total value human or goods of the structure to be protected. This is basically uh, the the risk assessment. The value of the probable average annual loss humans or goods due to the lighting relative to the total value. This is called basically the risk. So there are the four type of risk available. One is R1 is the risk of the loss and or permanent injury of human lives. R1 is basically the risk like the loss we have see in the above slides. The loss is basically the human loss. Then the risk is also related to that, the risk of the loss or permanent injury of human lives. Then the R2 is the risk of the loss of services to the public. The third one is the risk of loss of the cultural heritage. Like um, the same type of losses, same type of risk available. And fourth one is the risk of the loss of economic values. When these are the risks available, R1 risk, R2, due to that, the loss of humans' life. And in that type of damages, what type of damages? Injury to the living beings by electric shocks, physical damage, or failure of internal system of the human lives. Risk two, losses of the services to the public, physical damage or failure of the internal systems. The third one is the loss of the cultural heritage, the physical damage. Basically, no internal system in the cultural heritage, so it is the physical damage. Loss of economic values, injury to the living being by electric shocks, physical damage, failure of internal systems. So, due to that risk, this might be the type of damages. But these type of the risk R1, R2, R3, R4. These type of four type of the risk. We have to calculate these risks to analyze whether the risk is available in that area where we are installing our electric system or not. If any one of these risks is higher than the limitations value as per the IC standard, uh, we have to give the protection of the lightning. So now, uh, Sayyid Sharif, any issue? So these type of the four type of risks available. Uh, Sayyid Sharif, kindly delete these lines from the screens, kindly. So these type of risk available, we have to analyze these four type of risk, but their calculation is totally dependent on their risk components. So we have to give the risk formula um, in which there are the three type of things available. One is the ND. I will show after this slides to the IC standards. Multiply with the loss and also multiply with uh, the probability of that risk. So these type four risks will be calculated through. Okay, no issue, Shahrukh. Uh, so we have to calculate these risks. On that basis, we have to analyze what is the probability, the chances of the risk, and then we will decide whether it is in limitations or whether we have to give the protection. And then the protection design. I will show the practical example as per the Excel sheet I have prepared, in which uh, I will show one by one the risk component and everything. Protection design.
Please remove the skin line so hampering seeing.
So basically, basically the protection measure to reduce the injury of the living beings by the electric shocks. Uh, Adequate insulation of the exposed conductive parts, potentialization by the means of the mesh earthing systems, physical restriction and warning notice, and lighting equipotential bonding. Uh, when there are the chances of the loss of the human lives, so what type of protection we can provide by adequate insulation of the exposed conductive parts, eco-potentialization of the means of the mesh earthing systems, physical restrictions and warning notices, and the lightning eco-potential bondings. And then the protection measure to the reduce the physical damages by air termination systems like the finials, electrical lightning protection, the down conductor of the that finials, the earthing termination systems, and lightning equipotential bondings. These type of the four type of the we have to give it. And for the protection design,
Please remove the skin line remove. Skin
uh,
line remove, please.
okay, okay.
On skin sketch,
Basically,
please
Mr. Shah,
remove the skin.
I think Mr. Sharoff can delete these options. I don't. Mr. Sharoff, can you can you delete these lines?
Who sketch the lines, please remove the sketch.
Actually, I want to remove the lines.
Okay,
Okay, try to remove.
kindly. Basically, everyone, there are the some, I think, Zoom issue. They are ending the meetings in the 6 minute. I will generate again the link and share the group. So don't waste this webinar. I'm waiting, but due to the Zoom issue, they are showing that the remaining
Dear
time.
Azizul Hassan brother, dear
Yes,
brother Azizul Hassan,
yes.
please keep stop sharing option. Please keep your sharing option. You stop.
Okay. Okay, okay. Okay, brother. Just uh, I'm sharing again the video meeting link in the group. So kindly join that. Basically, they are showing the 5 minute, and I will when I will start the meeting, and they will end up that. There might be issue. So kindly join again in the next link. Okay.
Yes, please share the link. I will
Okay.
join next season.
Okay. 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 So we will start again. So basically, I'm talking about the protection systems. So the protection measure uh, to reduce the physical damage, air termination system, down conductor system, and earth termination system, and the lightning equipment bondings, and also due to the reduced failure of the electrical and electronic systems, earthing and bonding measures, magnetic shieldings, line routing, isolating interference, and coordinated SBD system. So these are the protection designs we have to give to the to reduce the the risk that can be occur, like the humans losses, the physical damages, or there are the different type of damages we have seen in the previous slides. So on that basis, I will show basically the calculation of the risk assessment. Uh, can you see the screen of the Excel sheet? Basically, I have talked about the risk R1, R2, R3, and R4. So we have to calculate these risks, and then we have to analyze the risk assessment. Uh, but the risk R1 will be calculated like I will show you that this one, the R1 is equal to the RA, RB, RC, RM, RU, RV, RW, RZ. Basically, these are the components R, A, B, C, M, U, V, W, and Z. These are the risk components, and R1 is the risk one. So we have when we have to calculate this risk one, we need this risk component calculation. Then we can calculate this risk R1, losses of the human lives. So how we calculate this risk RA, RB, RC, RM? So for that risk RA, RB, RC, like that, we have to need this formula. RA is equal to ND, PA, and LA. Basically, ND is the number of the dangerous event by the annual. How many dangerous event available of the lightning per annual? And the PA is the probability of the risk, probability of the of that chance, and L is the loss. So we need this calculation RA, RB, RC like the same. I have given this in the calculation of the RB, ND, PB, LA, LB, and also the RC, ND, PC, and like the same. So we have to need this calculation, proper calculation, RA, RB, RC, RM, RU, RV, and RC. Then we can calculate this risk R1, R2. So for R2 we need the RB, RC, RM, RV, RU, RZ. This calculation. So and for the risk R3 we need just RB and RV. And for the R4 we need all these type of risk components. So I will show one calculation of the risk component like here. So you need these three type of calculation. First ND value, PA value, and then LA value. So when we go into the IC standards 62305, they will give us these options. ND formula. ND is equal to NGN AD CD 10 power minus 6. So for that we need this calculation also. Then we can finalize our calculations. So this is basically the process. So one by one we need calculation every component. On that basis, at the end we will finalize our risk components. Then the risk component when we will finalize, on that basis we can finalize our risk calculation. And then when we calculate all these risks, like here you can see that RA is this value, RB is the value. These are the risks not available. Risk component is not present in area where I'm calculating these calculations. So that's why we put the zero value. I have sum up this all this value. Then I will go into the this R2 value and calculated all these value, and then we will finalize this risk two. Then for three, basically this loss is related to the heritage losses, and this loss is basically the due to the line present in the area. For the area where I am just calculating these losses, in that there are the node transmission line passing through this PV area, solar plant. So that's why these are the zero values. For that, these are the risk available. So that's why this fold. So these are the actually values, RT value, risk tolerant, tolerable risk available in the IC 62305-2, and they have given these values. We need to check this value as per our calculation. If this value is higher than these values, then we need to give the protections of that risk. So when we have checked that the risk R1, losses of human life, is higher than the tolerable limit. So we need to give the protection for that system. So for that we have calculated our risk calculations as per our protection design. Now again, the IC standard 62305 give us the protection values. Like in when we go into the 62305-3, table 1 and table 2, they totally give us the protection options. What type of protection we will give? Here we have given the less protection, like the level 4 protection, and we have calculated our risk analysis one by one again. Like the previously we have calculated, in that we have calculated all the value of the risk component, and then we have submitted all the options. And now you can see that our calculated risk is less than the uh, limited values. So as per this, we have to give the level 4 protection values. So how will we calculate the level 4 protection values? Just I'm going there. There are the three type of the protection methods. One is angular method, rolling sphere method, and then the mesh method. Basically, method, they have given us the values. Like they give us the maximum value of the rolling sphere radius, mesh size, and protection angular corresponding to the class of LPS. This is the class of LPS. This is the lowest L4, LPS4. This is the higher than this. This is higher, and one is the most costly protection level. Level 4 is the cheapest protection level. So you can see that this is the rolling sphere, circle of that rolling sphere. I will show in the AutoCAD file how we will check that. This is the 60 the radius of that rolling sphere. For 3 we have to give the 45. For 2 we have to give the 30, and for the 1 we just give the 20 radius. And for the mesh also, they have given the size of the 20 by 20, 15 by 15, 10 by 10, and then angular method basically not used in the solar plant, and mostly these are the two mainly methods used. But rolling sphere is the preferred method which is used. So I will show how we will check again. Like this is I have installed the MV stations in the PV area. You can see that there is a PV area available, and I have installed the MV station, medium voltage transformer, LV switch gear, and MV switch gear. And we have to protect this MV switch MV station. Now I have installed 2 lightning rods. This is basically the rod, and the lightning protection rod is just 1 meter. I just give that. And this is the radius of the 60 diameter. Sorry, 60 radius. When I have checked that the rolling sphere, when when like I mark that, you can see that this is the area under this rolling sphere. This is the area under the rolling sphere. This is the safe area. This is the safe area. But this area is not safe. So you can see that. So here you can see that this is 1.8 meter is available, which is under that administration. So this basically call that the penetration depth. This is called I will mark that, and I will check real life from that. This basically 12.48 meter is the penetration depth of that rolling sphere, and this 1.8 is the safest distance. We need this distances when the rolling sphere, this gives the safe distance. We can say that our protection is okay. The separation distance between the two rods is okay. We can give that. Like in that area, I have mentioned this the lighting rod on the solar structure. You can see that this the rolling sphere is going down that and touching to the solar panels. So you can say, I'm saying that this rolling sphere is not protecting the solar panels. So we have to uh, decrease this distance. Like here is the 28 meters distance. We have to give the less distance. Like I can move this. Like here, I have moved that, and I will rotate this option. Now you can see that this is a clear. Now this distance is okay. We can install the lighting arrangement at that option. So basically, this is the lighting protection systems. How we will analyze the risk assessment. So basically, I just want to give the basic concept of the risk assessment, how we will analyze our risk, and how we will give the protection to our systems. So if you go in the depth of this risk assessment, how we will calculate, how we are just I have prepared the Excel sheet, and you want to become the professionals, and you want to prepare the Excel sheet like that in the manuals. So for that option, basically in 1 hour, I'm just give you the basic idea of the lighting protection systems. But if you go into the depth of that, for that I have just prepare a 1 week training program, which is starting from the tomorrow. Like this is the same times like 9 p.m. Pakistan time to the 10 p.m. 1.5 hours training, and I will show in the depth how we will calculate one by one risk every like R1, R2, and R3. What type of the basics we need for that? What type of information we get from the sites? So if you want that, uh, I'm giving the training. So for that training, the charges is 11K PKR for the Pakistani students, and for the international student who have joined me, the price is 40 USD. But if you want that training, I will give you the four for the next four of the discount values. The 9K PKR for the Pakistani student and $32 for the international students who want to join that trainings. You can go into the. I'm sharing in the chat. Uh, Basically, give me a minute. First of all, everyone should fill this form for the attendance sheets. Basically, it is for um, the certificates. So you can fill this form, and from that I will give you the ID, give the certificate of this training. And for the paid training, I'm just sharing this link, so you can you can join this training if you want. It's not mandatory. It's up to you, all of you. You can follow me on the LinkedIn, Instagram, and Facebook. Now I'm stopping my screen. If you have any question, you can ask me. Everyone should raise hand and ask the question. Yes, Mr. Narendra, any question? Anyone? Mr. Narendra is from my previous course, also has joined my course for the solar system designing. Mr. Narendra, you can share my reviews to all of the audience. Can you hear me? Can you hear me?
Yes, I am hearing you.
Uh, have you any question from the students? Yes,
I
yes,
have some question.
yes.
How many voltage and current level lighting strike?
Sorry.
How
Basically,
many voltage and current level lighting strike?
from your background, some noise. I'm not clearly listening your words. You can write in the chat. You can write in the chat. No issue.
Hello, sir.
Yes.
Hello, sir. I'm asking about how long will the building can reach? Like how many meters that can likely the lightning can likely strike it?
How many height of the buildings on which the
Yes,
light?
sir. Yes, sir.
Yes.
Yes.
Basically, it depend upon the risk assessment. When we are doing the risk for the buildings, we have to check the height, the area. So when we calculate this area of that buildings, then we can analyze that at what height this lighting strike or it is in the protected. When we do the calculation in the details, then we can analyze the height of the buildings. Without assessment, we can't analyze that at what height the lightning strike at or at what lightning not strike.
Okay, sir. The second question is that, sir, there is one scenario case that just happened this raining season with one solar power plant
Okay,
for a mosque.
okay.
So it was just thunder. After the thunder, then the strike, the lightning strike. So the solar system stopped working at all. So I'm asking what will be the cause and why they did not provide anything like protection to that solar.
Basically,
Hello, sir.
sorry, I'm listening to you, but what are the some of the measure do we consider while choosing the earthing pit area? And so basically, when in the solar power plant, the lightning strike and due to the some the lightning strike the system will damage like the inverters and everything. So this is the basically the loss of the systems, and due to that the energy will be lost, the price, the capital loss. I'm just getting this point. I think your the question is about that. Basically,
Yes, sir.
yes. So when the lightning is strike, and we have not given the lightning protection systems, it will damage our solar systems, the inverters, MV station. So this is the capital loss. And it may be a chance that when the some people working in that area due to that lightning strike, the loss of the human lives is also present in that area.
In the area, what happened is that I think what I'm asking again, sir, is it that thunder, the sound, does it have effect or less that strike? The sound of the thunder will come before the lightning. So
Okay.
I'm asking whether the sound also have effect or it is just only the lightning that is having
No, no,
effect
no,
on the
not sound,
process.
not sound. When it strike, when it strike the lightning, it will affect.
Mhm. Okay. Thank you. But there is no loss of life, nothing like that. The people just hear about that lightning, the sound, and then the lightning occur. But God so kind, nothing like loss of life. It's only the power plant that got damaged. So
Basically, basically,
possibly not.
basically
Mm.
basically the losses reason is that the lightning current when the lightning strike on the some human lives or in the structures, the lightning current will pass through that area to the humans, and then they will damage, like the lightning current is passing through the humans, it will totally damage the humans, or it maybe some area will be damaged through that, or when the current is passing through the inverter and the solar panels, it will damage, and it might be chances that the fire will blow up like that. When the just the cloud is type of the rain occurrence options there, it will not affect when they actually strike on the system. this will damage our systems.
So, okay,
Okay.
thank you, sir. And so, sir, what can you say about those that install these types of funnel? You see many more funnels, and there is nothing like that protection, and they didn't have effect on the solar system. What, how can you advise, or what can you say about those that are installing it? Are they not following the real design, or they are just doing it offhead, or they know it and they are just leaving the protection because of saving costs or something like that? So what can you say about this negligibility?
Basically, when you are designing the solar systems, like the in the power plant, uh, the client will not accept without the assessment of the lightning strike. When we do not do the risk assessment, we can't say that your system is protected from the lightning or not. If we do the risk assessment and we calculate all the four risk type of risks like R1, R2, and R3, and you can show to the client
Mm.
that these four risks are within the limitation of as per the IC standard. These are the limitation as per the IC standard, and our calculated risk is under this. The risk calculated risk is under the tolerable limits. So then you can say to the client that our system is protected from the lightning. Without that risk assessment, you can't say that, and client will not accept without this risk assessment your project.
Thank you, sir.
Okay, welcome.
Hello,
Uh,
sir.
okay,
So
sorry.
if I may ask something or some advice again, sir. I'm just a recent graduate of electrical engineering, and I have many passion in this solar system design.
Okay.
So what we are facing in our area, I'm from Nigeria. What we are facing in our area is that you see in
Uh,
this work, they do not care about all these protections and something like that. That is why things are happening like this. So what can you say about this, and what can you give me an advice and a way to follow as an engineer, just recent graduate? So how can I improve this thing and give awareness to the client and something like that? Because they
basic
are just always fear about this economic factor. They'll say minimize cost. That's why they do not care about these protections. So, sir, what can you say about this?
Basically, from that area where I am living in that area, there the might be issue is that in the area which countries are not developed, they basically say that the cost of the protection system, but they don't say that the protections proper designing. So that is the main reason in the like in my country, Pakistan, and your country, they don't care about the proper designing. They just say that how can we save our cost, but they don't see the consequences of that options in the futures. When they the light strike on the in the future, they damage the solar system. Our at that time they said that how can now we can what we can do that. So that is the main reason I will advise you that you can try to involve in the international like the companies which are working in the different country like the South Africa. Basically, the South Africa is the main hub of the solar system. So you should try to give like gain the jobs in that area. So for that will be a good option for you to understanding for the growing perspective.
Thank you, sir. I really appreciate it.
Thank you. So
Okay.
I will give how many voltage current levels likely. Basically, as such, I will giving you your question answer. Basically, the current will give the options for the losses in the lightning strike, but it will be calculated as per the lightning strike per year. When we are going into the depth of the lightning strike assessment, we will need the lightning strike per area where we are installing our electrical and solar systems. We need the lightning per year. This will be we got from the IC standard and from the local standard. On that basis, we will analyze that what type of the risk available. Only we can say that voltage and current we can't measure of that. What are the some of the measures do we consider while choosing the earthing pit area? Basically, Kevin, when we are choosing the earthing pit or the mesh area, we have to analyze the step and touch voltage and the ground resistance. On that basis, we can analyze the pit area of the earthing systems. And the Marco Martin square foot light to we put on the top of the PV modules instead of being stand along with it on grounding. Marco, basically there are the two options. One, we will install the lightning finials on the mounting structure, and for that we have to follow the IC standards. IC standard will give you the thickness of the mounting structure. If the mounting structure thickness is as per the IC standard, we can install the lighting finial on the PV module structures. If the thickness of the mounting structure is not qualifying the IC standard, then we have to install the finial like the separate, and we have to give the separation distance from the mounting structures. So these are the two options we can go there. So this is basically you have to fill the attendance sheet and also the paid trainings. If you want to join my trainings, you can fill this form, and hopefully by tomorrow we will meet again. So I hope you have gained the new knowledge from this webinar, and this meeting will be ending. Hopefully we will meet again in the tomorrow. Okay. Allah Hafiz. Thank you. Thank you everyone to
Okay,
join.
thank you so much.
Thank
Assalamu
you.
alaikum.
Assalamu alaikum. Thank you everyone to join this webinar. Okay. Allah Hafiz.